Okay, let's check how you did. Now, if you look at the numbers that I have up here, my computer circle is 11 and 6, that makes 17. My board game circle is 6 plus 4, that makes 10. And if you add up all the numbers, they add up to 30. It works, but how do we come up with those numbers? That's the hard part. The only number that we knew for sure was the 9 on the outside. So one way of looking at this is if you start with your 9, because that's what you know, and you say, I know that there's 10 that play board games, and I add 10 to my 9. And I know that there's 17 that play computer games, and I add those up, I get 36 people. What's the problem? There is only 30 people. But now if we take out our special coloring, you know I wanted to just color, right? So let's do orange, because apparently orange is the happiest color. Let's go with that kind of opaqueness. If I count my 9, that's my outside ear. Oh, doesn't that make you happy? Okay, there's my 9. Then if I add my 10, that'll be this circle here. Then if I add my 17, that'll be this circle here. Can you see that I added the middle section twice? And how much bigger than 30 am I? I'm over by 6. And since I added that middle section twice, that tells me that there has to be 6 in that middle section. Does that make sense logically, how we can figure out that that middle number has to be 6? And then after we get that 6, well, we know the whole board game one has to add up to 10, so we can find the 4. And we know the whole computer one has to add up to 17, so we know that has to be 11. Yes. Yeah. Okay. So then we can figure out our probability after that. What are our chances of playing board games? Well, now there's 10 out of 30. That one was easy. Computer games and board games, we can figure this to be 6 out of the 30. And plays board games but not computer games. So we have to find the board games, has to be in the board game circle, and not the computer games is only going to be 4 of them.